on the abacus. When we count on the abacus, we're going to count. We have 1. This is 0. So that means it's 0. After we have 0, we're going to do 1. So this is 1. After 2, 1 is 2. After 2 is 3. This is 3. And there we go. So this is 4. On the abacus, this is 4. Notice we have the top bead. Notice we have the horizontal. The horizontal bar is what tracks the information. It's what tracks the beads. When we track the beads, we're counting it's a horizontal bar because there's a horizontal bar. Then if we look at it, this is 5. This is the top bead. The top bead always has a value of 5 because it has a value of 5 and it's being counted. This is being counted, so now we have the value of 5. So when we count, oh, what does 5 look like? Well, we know what 5 looks like. 5 looks like that. So 5 looks like this, and then there's 6. 6 looks like this, and then 7 is this. How do I know? 5, 6, 7. Notice that we have 1 bead on top and 2 beads on the bottom. So when we're looking, it is 5, 6, 7. Where are you? Just trying to check on a few things. Oh, there we are. So then we have 8. On the abacus, we have 8. This is what 8 looks like. And then we have 9. After that, we have 9. 9 looks like this. Hello, everybody. Welcome, welcome, welcome. Hello. Let me know if you have any questions. So what we're going to do is we're counting on the abacus. When we count on the abacus, we want to be able to understand how to read it. So if we have 1, this is 1. And we're just counting again. Where this is 1, and then after 1, we have 2. That's what 2 looks like. Notice there's 2 beads here, there's 2 beads here. This is what 2 looks like. And then there is 3. Thank you so much for the likes. This is 3. After 3 is 4. That is 4. All right. Okay, good. We're set. So this is 4. Notice how this is 4? Okay. So when we look at it, now what do? This is 5. How is this 5? I feel like that I'm doing this is a hook, and then this is a hook. Okay, sorry. So this is 5. On the top bead, it has a value of 5 because we're counting on the horizontal bar. Anytime that the horizontal bar is touching this, anytime the beads are touching the horizontal bar, we're now counting it. So this top bead is touching the horizontal bar. We are now counting it. So when we count, this is 6, 5, 6, and then this is 7. How do I know? Because when we look, we have our 5. The 5 has a value of, the top bead has a value of 5, 6, 7, and then 8. After 8, we have 9. After 9, this looks very familiar, doesn't it? This looks like it's 10. But if you look, 10 is the same thing as 1, just in a different location. So this is 1, and then 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 this is 1. So they're all the same, but the difference is the location of the columns. It's the location of the beads, right? What does that mean? Well, when I look at it, every column has a place value. So we have our 1s, our 10s, our 100s, our 1000s, and our 10,000s. Does that make sense? So welcome, everybody. Welcome. Hello, April and Alice and Yura. So when we look at it, we have 1, 2, 3, 4, and then we have 5. 5, 6, 7, 8, 9, and then notice we have 10. 10 looks like that. So 10, as we write, looks like this, right? We know what 10 looks like. So how do we read it on the abacus? Well, if you notice, it's a 0 and a 1. So all I got to do is this 1 and a 0. That's what 10 looks like. Thank you for taking the time to teach us. I was debating getting, oh, really? Ha, 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 ha. I would highly recommend it. Yeah. Let me know if you have any questions. Let me know if you have any questions. Thank you for the follow. And what made you decide on getting an abacus for your child? Let me, please, I would like to know a little bit more. Thanks, I see why. What made you decide to get one? What made you go down this path of getting the abacus? Was it my lives, or was it just randomly like I wanted to teach my child something different? So yeah, let me know. I'd love to know. I love to know like everybody's journey on how they get to understand abacus. So we have 10 and then we have 11. Notice this is 11. How do I know? Because this is 1 and 1. And then we have 12. 2, right? It looks exactly the same as how we write it. 2 and 1. exactly the same. This is not rocket science. This is just reading the abacus. What we're doing is we're reading the abacus. Why? So then after we learn how to read the abacus, we can add, subtract, multiply, and divide. So the first thing we're going to do is we understand how to read the abacus. So we're going to do another review. When we look at it, here is my abacus, right? My abacus. So when 1 looks like, that looks like 1. And I'm going to use this one. So what we want to do is we want to color in the top bead. When we color in the top bead, we know that this is 1. And then I have 2. Well, how many beads is 2? Well, 2 beads. How difficult is that? That's not very difficult. There's 1, there's 2. So 2 looks like that. And then 3, 1, 2, 3. This is 3. And then we have 4. 1, 2, 3, 4. 4 on the abacus. Oh, we have 5. 5 looks like this. 5. And then we have 6. 5 on top, 1 on the bottom, so that's 6. Years ago, I researched math materials and parents were recommending, and then my mom wanted for mine. Oh, yeah? For me. Oh, so do you know how to read the abacus? Oh, and then this is 7. 5, 6, 7. When we look at it on the abacus, we do 5, 6, and then that's 7. And then here is 8. 5, 6, 7, 8. 5, 6, 7, 8. And then this is 9. 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. Her child, for my child and her grandchild, I never stopped to break down how to actually use it. Oh, welcome! Welcome to the real world. I will show you and explode your mind. It's very quite easy. It is very quite easy. And so how old is it okay? I ask how old your child is. Because I do have exercises and worksheets, unless you have it, which is fine too. But I know it's a little bit interesting. It's always interesting to see everybody else's like path and stuff. So, I learned abacus not as a child. I learned it when I was old, and that was only because my dad went on a business trip, and a lady who had a child that had not Alzheimer's, was a little was on this was autistic because this was a long time ago. This was 20 years ago, and she was like, "You got to bring abacus to America and teach the world." And my dad's like, because my dad's a Chinese man, he's like, "You're gonna learn how to read the abacus," and I'm like, "I don't even know what it is." And so he forced my brother and I to read the abacus. I was getting it for my child and my nieces for use it. Oh, she's 6. Oh, fantastic. So what's gonna happen is the first thing she needs to do is, she knows how to read her numbers. So then what I would do is I'd probably go into understanding how to read the abacus and do some number placement. So I have some activities that she can start off with and understanding how to read the numbers. So this is a maze that I've created, and again, this is just to reinforce how to read the numbers, and we can go through it. So here it starts with the number, right? What number is this? So if we look at the abacus, I don't know, maybe I should do this. There we go. Maybe I should do that. So if I look at the abacus, what number do we think that is? So again, what we're trying to do is we're trying to see, right, how to read the abacus. And so I guess I got to move it up a little bit. There we go. So if I'm looking at this number right here, what number do you think this is? And right. So we have 5 and then 6. 5, 6, and then there's 1 here. So there's 1 here. I would recommend it. I have 3 boys. Thank you, Cookie. Yeah, 61. So, hey, JP, I would recommend the abacus just because I believe it's the greatest thing next to sliced bread. The other reason why is to make sure that they understand like the numbers. And what abacus does is it provides a foundation. So my question, I guess my question to you would be like, how much do you know about the abacus? I mean, to really understand it, I will go through the whole thing with you. We can do adding, subtraction, multiplication, division. But the first thing we would do, the first thing we would do is understand how to read the abacus. And that's what we're doing right now. So here's a couple of worksheets that I've created. And if this number is here, what number would this be? If I have that number, that's 3. How do I know that's 3? Because I count 1, 2, 3, and then this one, 1, 2, 3, 4, 5. Nope, 5, 6, 7, 8, 9. I'm sorry. I don't know what I'm talking about. So what number do we think that is? Um, hey, Tech Druid, welcome back. I haven't seen you in a little bit. It's been a moment. So what number do we think this is? If I have 3 over here and I have 9 over here, when we look at it, thank you, Brandy, it is 39. So we're going to color this in and we're just going to follow. Thank you, Marlene. How can you do multiplication with the abacus? Yes, we can do multiplication with the abacus, but for right now, we're going to learn how to read the abacus, and then we'll learn how to do adding and subtracting on the abacus. And then after we do that, thank you, Marlene, after that, then we can do into multiplication. Because there's no point of understanding multiplication if you don't know how to add and subtract. 51. Oh, good. Thank you, Nisa. 51. Sadly, I'm having a hard time understanding how to do anything, sadly. Brandy. So do you understand how to read the abacus right now, Alyssa? So now we have this number. We have 5, 6, and then we have 4. 1, 2, 3, 4. So when I change it, when I move it to my abacus, when I have it mimic the abacus, it looks like this. That number to this 64. Thank you. Really? Not at all. Thank you, Brandy. Really? I'm so happy you think so. Because this is a book. I'm creating a book. So, not at all. Okay. Hey, Barbara! Welcome back! Okay, so, Alyssa, when we were talking, when we read the abacus, we want to know what this number is, right? This is 1, this is 2, this is 3, this is 4. So because this is 4, anytime the beads are touching the horizontal bar, this is considered 4. These are considered counted. I'm sorry, considered counted. Welcome back, Axel. So here we have 4. Because the beads are touching the horizontal bar, this is 4. None of these beads are touching the horizontal bar, so these are all 0. Does that make sense, Alice? Alice? I'm hoping I say it correctly. Alice. Okay, so what's our next number? If we have this, 1, what number is that? Did that make sense? Let me know. It doesn't matter what bead. Does it matter what beads you use? It does actually, Axel. What it means is, thank you, Brandy. The reason why I'm doing this one here is because I have a label. Haha, I always forget the name. I have a label. This label is this thing right here, this dot. So, thank you, Brandy. So, what happened is I can choose this label for my ones place. When I look at it, I have my columns. I have my ones, my tens, my hundreds, my thousands, and my 10,000. So, if I wanted to, notice I have a label here. If I really wanted to, I could use this as my label. So, what I could see is my ones and my tens, and notice I don't have my hundreds. So so that's why I would have more beads over here. So this is 3. It can't make sense of it, but I don't think it's you not making sense. I've been told I have a math disorder, apparently. Oh, okay. Okay. Okay, apparently. I'm wondering, first things first is, do you understand that this here is my ones place? Did that make sense? And I will wait for your answers. Because I'm curious. I'm curious about it. I had a couple of people that go through. I had a couple of people that I've taught that were autistic and so forth. And so they actually did quite understand it. And I wonder if it's the speed that I'm talking, because sometimes I know I talk really fast. So before I continue, when we look at it, 1, 2, 3, 4. No, I wasn't sure. I was trying to find out where the ones place is. I'm also autistic. I'm not laughing at that. No, you're fine. So what it is, here, what it is when we're looking at it, and that's the thing, if you can tell me where you're lost, I can tell you where the things are. So because you don't know where the ones are, I wanted to tell you this is where the ones is. So this is what 4, 1, 2, 3, 4, we know what 4 looks like. what we're doing is understanding where the label is, and the label here is this dot. This dot is my indicator. It indicates that this is the ones place. Does that make sense? So when I do this, when I move the beads down away from the horizontal bar, that means the beads are not being counted. When I put the bead to the bar, now it's being counted. Now, this is a value of 5. This will always have a value of 5. Here, this is what makes it better. We know what this is, right? In America, we know what this is. This is a nickel. I don't know if you're in America. I'm just assuming that we're in America. This is a nickel. A nickel is 5 cents. Notice, pretend this 5 cents is, okay, good. Pretend the 5 cents is the top bead. And then I have pennies. 1, 2, 3, 4. Every penny is one bead at the bottom. Does that help? So when we're using this, we are now taking it away. When we bring down the 5, we add the 5. We add the nickel. So pretend that this is a nickel. Yeah, I made that epiphany today and I was like, "Oh my god." You're not the only one. So when we put these together, 5, 6, when we put it together, this makes 6. This is also 6. Does that make sense? When we're putting the coins together, this is 6, right? So 5, 6. Then we want to do 7. 7, 5, 6, 7, right? 8, 5, 6, 7, 8. 3 pennies. And if I'm too loud, I'm just really excited. I'm just really excited. This has been oh great. Thank you, Sasha. Okay, so what number is this? If I put this together, what number is that? I've learned so much in the 10 minutes I've joined. So awesome. Oh, Nisa, thank you. Thank you. Does that make sense, Alice? So now, if you notice, when I remove it, I only have 4 beads left. I only have 4 pennies left. This 5 cannot be broken. This 5 cannot be broken. Maybe it's out of titanium. I wish it was out of titanium. Same. Oh, great, Cookie. Great. So does that make sense? So what we're trying to do is we're trying to relate the numbers and the beads. The beads is related to the money because we understand what money is. So I'm just this was a game changer for me when I realized I could use a nickel. Woo! Brandy Samuel Fleming's never read an abacus before. Yeah. So an abacus is just a counting tool. That's all it is. And I'm just fidgeting. Okay. So we're going to continue with my little maze. Now I have this one over here. I have this number. What number is that? What number do we know what this is? What number is this? 5, 6, 7, 8, 9. 99. Thank you, Deanna. Yes, you're absolutely right. 99. So I'm going to color this and I'm going to come down here. So my next number is this. So we have this and then we have that. So, hello, Marlene. Thank you, Marlene. Yes. Thank you, Diana. Okay, Alyssa, do you have the color version of your maze? Do you think it would throw it off if it was colored? Yes, it's 91. You know what? The reason why I don't have it colored is so I wanted you to color it. That was the reason. 91. Thank you, Sasha. Yes, 91. Because the idea was the user, when I had this, right, you're going to have it as a piece of paper. It's on a printable right now. Atticus! Atticus! um, the reason why I did that was so then the user colors it in. So they would check it off like this. So you're watching me do it, right? It's different. But that was the idea, is that the user does it. So I have 5, 6, 7, 8, 9, and then I have 1. Gillian, right? So then we have 9. That's the reason why it's blank. And now we have this number. What number do we think this is? What number is this? Hi, Amma! Amma, I got your answer. I don't know if you saw my post, but we'll do it in this. We'll do it in this 71. How do we know? 5, 6, 7, and then oh, Sasha, Sasha. Hello, Barbara. Yes, yes, I figured it out. And it was because I was crashing. Sasha, no, it's not one, it's five. Because it's the top bead. So this is the top bead. So we have five, six, seven, and then the top bead. Hey, Melinda, 90, whoa, 91. Whoa, yeah. Yeah, yeah. So that's also the thing, right? The thing is it's a skill to practice is the attention to detail. Where's the okay, good. Okay, good. There is an answer. I thought I had to rewrite this. All right. So we have that number. What number is this? What number is this? Yeah. So we have five here, right? And then we have one, two, three, four. We have four. Sasha, good job. Melinda, Alma, Brandy. Hello. Nisa, good job. Good job. Good job. Okay, so I'm coloring it in so I know we already touch everything, right? Because I don't want to go into a loop. This is not an infinite loop. I'm still talking about you. Atticus. So funny. Okay, two, and then we have this, and then this. Alyssa. Yes, Sasha. Yes, Melinda, Marlon, Alma, Brandy, and Nisa. Yes, 25. And then we go up. We're almost done. We're almost done. What is this board called? Axel, this is called an abacus. Abacus, not Atticus. Because we have a person in the chat called Atticus. It's called an abacus. 58. How do I know? Five, five, six, seven, eight. You're confusing everybody, Atticus. 58. 58. Yes, fantastic. We have one last one. Don't confuse. Don't confuse it. So we have our last one. We have one. Oh, we should do that. Yep, there we go. No, you're confusing me. Atticus. You're so funny. Four, one, two, three, four, one, two. Yes. Thank you, Melinda. Thank you, Brandy. So, Alyssa, did that make sense? What we're doing is we're just reading the abacus. And then what we're trying to do is once we understand this, I think we're all getting the good feeling about it. We're going to actually start going into adding and subtracting. So let's do some adding and subtracting. I'm struggling with this, but I'm determined to read something before bed. Did the okay, here's a question. Did the money make sense for you? Maybe it would help to have the money because what it could be another thing is because you don't have the abacus with you. The answer is to the universe. Yeah. Alyssa, you might want to get some money, and that one might help you because it would be easier to see and touch. So if you can, maybe that would be a thing. The first sheet before this game was clear. They have another one. They that they made again for a list. Good night. Oh, have a good night, Amma. Um, Alice. So what I would do is if you're trying if this has been difficult because it's visual, I would recommend to find something. Try that one again. Try what again, Brandy? Try this one again? I think it would be I think it would be better if you had something to touch. So if you have like some beads or something, try the sheet before the game. Oh, this one. Right. I got it. I got it. I got it. I got it. You're right. Okay, I got it. I got it. So let's try. Okay, let's try this. This is it. Okay, let's try that again. Okay, so a bit, but I could figure out the place value with the five. I got stuck somewhere. Yeah. Okay. So we have one, right? We know what one looks like because one is just this. When we read it, when we read it, we have the one bead. So we're going to do one penny, right? So then after, and then that's again the reason why the reason why the sheet is blank is so then you can come in and you can color it in, just so you can have that interaction. And that was the reason why I did it this way. So then when we want to do two, we want to color it in. One, two. So then that would be two beads. That's two beads. And then we have 3. So we have 1, 2, 3. So this is 3. And then after 3 is 4. 1, 2, 3, 4. Do the colors represent the place value? No. If the colors are confusing, let me change that. The reason why I do colors is just it's fun. But on a regular abacus, this is a regular abacus, it's just the positioning of the beads. So when we look at it, it's just the positioning of the beads. We just want to move the beads up or we move the beads down. This is 4, so that means all the beads are touching. Yeah. It doesn't matter about the color. Don't be, yeah. It doesn't, yeah. Does that make sense? So when we're adding 4, it's touching the horizontal bar. I don't know if you can see that. I'm using this one right here because I have an indicator. This indicator tells me it's the ones place. That's why I'm here. So because I'm here, I have 4. Now what happens with 5? Hello, Ariel. 5 is my one dime, right? My dime is only the top bead. So again, I'm just going to color in the top bead. That's the only thing that the abacus sees. The only thing that the horizontal bar is the dime. I'm not dime, sorry, nickel, right? The 5. This is a 5. This is 5 cents, right? 5. So the top bead has a value of 5 no matter what. No matter what. You can't go without it. So each column of the beads is a number from, yes, exactly, Marlene. So when we do 6, right? 6 and 1. That's what 6 and 1 looks like. Yes, you're absolutely right. Fantastic. That's good. So it makes sense, right? So what we're going to do is we're just going to go down how to read the abacus. So we have 5 and 6. Notice I have the 5 bead, right? That's the top bead. And then I have the one at the bottom. So then we do 7, right? 7 is 5, 6, 7. We have 7. Does that make sense, Alice? Are we still catching, is this still make sense to you? You have to let me know if the minute that it doesn't make sense. Because I don't want to keep going ahead, right? It's always good to review. Okay. Are we going to do 8? So how do we do 8? 5, 6, 7, 8. Do it. Okay. So how do you make 10? Oh, here's 8, right? And then there's 9. 5, 6, 7, 8, 9. That's 9. All right. I'm going to go back to this one. Marlene, if you notice, we know what 10 looks like. Maybe you can go ahead for the others and I'll come back and I'm still stuck. Okay. Okay. Okay, if you're still stuck, okay, let's maybe take a little breather, right? Because sometimes it takes a while to understand because it's a new way of thinking. Marlene. So this is 1. If we know this is 1, we know this is 2. If we know this is 2, guess what? We know that this is 1. What does this look like? This is actually 10. 1 and 0. Now we can count by tens. Ah, see? So next column is the, yeah. So here, if we look, it's the ones and the tens. So we have 10, 20, 30, 40, and then we have 50. After 50, we have 60, 70, 80, 90. After 90, we have 100. So every column is a place value. Every column is a place value. Every column is a 9. There's always going to be 9 no matter what. It just depends on your place value. Just how we write. When we write, right? When we write, we have 9. We don't have 9. We have 900. So we have 900. Does that make sense? So when we looking at it, don't forget the zeros. It's okay that you don't do this, right? Because it's a decimal. We don't work with decimals afterwards, right? What if I did this 0.1, right? Then there would be 0.1. Oh, sorry. 0.1. We have 900.01. So now we're talking about money. I wish I had $900 to show you, but I don't. But after 9, right? After 9 is 1,000. Again, it's 1000. 2, 2,000, 3,000, 4,000. That's why learning how to read the abacus, that's why I go a little slower. I wish I could stay to learn more. It's better. Oh, yeah, Brandy. Have a good night. I'll see you in my next live. I'm always on live. So when we read it, this is 4. This is 4,000. When we see 4,000, we can understand our place values. When the way we write is exactly the way we read on the abacus. That's the same. That's it, hands down. How we write it is exactly the same how we read the abacus. There's nothing else to that. That's as big as goes. Okay? So if you're asking me what's after 9? Well, what's after 9 when you write 9? 10. Hello, Agnes. I was on your live yesterday and it was really interesting. Yes, Agnes, I remember. It was, oh, yeah, that's right. That was yesterday for you. Yeah, it was this morning for me. Oh, but Agnes, I found a new way of explaining the 5. And I was going to do a nickel. I don't know if you have nickels where you are, but we could have a nickel. It's a 5 cent. This 5 cent is going to be the going to be the top bead. And as we add the top bead and remove the top bead, so we have the top bead and then we have the bottom beads: 1 penny, 2 penny, 3 penny, 4 penny. I don't know if you guys deal with pennies and nickels, but I thought that was really interesting. So I'm in California. I'm in America, so we are a little okay. So that's what we're doing is we understand how to read the abacus. We did the maze, right? After the maze, we can now start doing some adding and subtracting. Yes, I've always wanted to learn how to read the abacus. Yes. So after we learn how to do the maze, what we're going to do now is we're going to learn how to add and subtract a little, a little. I don't know what the comment was. I don't see anything. I don't see anything because I think it's been filtered. Okay, so what's going to happen is we're going to understand how to read the abacus. We're going to learn how to add and subtract on the abacus. Now, when we add and subtract on the abacus, you need to know we don't focus on the answer. What you focus on? Oh, American, we are a little. Oh, yeah. Um, when we focus on is we focus on the add-in. We want to make sure we understand what the add-in is. That means that we're going to understand what this is. When we read the abacus, I want to add, let's do this one. We're going to add 5. So this number is 5. We want to add 5. We add 5. Then the next number is I want to add 1. I only have 1 bead, so I'm going to only add 1. What I want to show you is I'm only going to add the 1 bead. I don't care what bead it is, I'm adding only 1 bead. Does it matter about the color? No, it doesn't matter about the color. It just matters if I have the 1 bead. So when we look, this is 6. So we have 5, 6. After 6, we have 7, right? So if I have 6 and I want to add 1, all I got to do is add the 1 bead. Notice it's a 7. Notice it's a yellow bead, but the color doesn't matter. What matters is moving the 1 bead, and that's all I'm doing. So the next one I want to do is this one. This one is 1. So the idea here was just to know what the 1 looks like. And then here is add the 7. So 5, 6, 7. So I'm going to add 7. Notice I bring it together at the same time. 5, 6, 7. I bring it together like this. My answer is 8. Here, my next question is 8. After 8, I want to add 1. So on my abacus, I have 5, 6, 7, 8. I have 8. And now I want to add 1. When I add 1, I just add the 1. I was actually waiting for that. So that's how we get 9. And then what happens is we can add 2. Again, we focus on the add-in. You guys are so funny. All right. We focus on 2. Again, The number is the second add-in. Why? Because we have the 5 and then we have 2. We're adding 2 beads. 1, 2. We're not, it doesn't matter what 2 beads we're adding. We're just making sure we add 2 beads. Notice it says 2. So my final answer is 7. 5, 6, 7. And then we have this one. We have this one. We have 7. After 7, we have plus 2. Notice there's 2 beads here. So I have 1, 2. I'm going to add these 2 beads. So my final answer is 9. So the difference between this is that what we're doing is we're just adding and making sure that we have enough beads. That's the question. Do you have enough beads? Yes, I do. So I'm just going to add the beads. This is called simple addition because we don't have to worry about formulas. We don't have to worry about using formulas. Okay, so again, that's 2, and then there's 3, and it's a slow progression just because I want to make sure that everybody understands how the beads move. Because once the beads move and you understand it, then we can go flying. But it does take a little bit to understand how the beads move. So this is 5 when I add the 5, and now I want to add the 3. I'm adding 3, 1, 2, 3. I'm going to add 3 beads all at the same time. I move them up to the horizontal bar, and now this bar counts to 8. Does that make sense? So when we keep going, I'm going to add 3 again. Here, I'll do 3 down here. So we have 6. So on my abacus, I have 6, and then I have 3. 1, 2, 3. I add 3 like that. So my final answer is 9. Again. So now we have 4. Again, we're looking at our second add-in. We're looking at our add-ins. 4 doesn't have a lot of questions. The reason why is because there's always this 4 beads. So when we look at it, we have add the 5. That's what this is, plus the 5. And now what we're going to do is we're going to plus 4. We're going to add 4. 1, 2, 3, 4. We're going to add 4 all together at the same time. And that's it. Does that make sense? Axel? Nisa? Oh, I think Nisa left, right? Does that make sense? So this is 9. So what we're doing, so now we know how to add. Because we know how to add, now we will know how to subtract. Subtraction means, oh good, Marlene's still here too. What subtraction is, moving down. It means we're going away from the horizontal bar. So we have it, this is the horizontal bar. When we add, we go to the horizontal bar. When we subtract, we go away from the horizontal bar. So this is -1. So that's what we're doing. Now, after we add, we know how to subtract. And it's the same thing, right? The thing is, we're just taking away 2 beads. So this is this is -2. So all we're doing is we're taking away 2, 1, 2, and then we're going away from the horizontal bar. This is how we show children how to subtract. Because we can subtract, it's easy to see when we add and subtract. Now, this is very critical because when we start doing our more complex adding and subtracting, understanding that there is a pattern. Now what we're doing is we're understanding the pattern, right? We understand that when we want to take away the 5, we move it away from the horizontal bar. When we want to add the 5, we want to bring it to the horizontal bar. So I'm going a little bit slow just so you could see, because it's a lot to take in. So now we have 1, and I want to add 6. When I add 6, I'm going to do 5 and then 6, 5 and 1, and bring it together, and that is 6. So after we do -2 and -3, we go to the upper beads, which means to minus the 5. Now we're taking away the 5. It's the same thing. We have 5, that's it. And then we add 1. Oh, sorry, we add 1. We add 1. And that's all it is. And my final answer is 6. So again, when we add the 6, we add the 5, we add the 6, we go to 7, right? Hello, Ethan. Good morning. So we have 1. We have 1, and then we have 6. So we're adding 6. My answer is 7. So this is simple. The reason why it's called simple is because we have enough beads. And then because we know how to add, add 7, add 8, add 9. After that, we need to do minus. And it's the same thing. We're just taking it away. So we add the 5, we take away the 5. That's all we're doing. We add the 6, we take away the 6. We add the 6, and we take away the 6. It doesn't matter where we do it. So if we add 8, right, 5, 6, 7, 8, and we take away 6, 5, 6, we take away the 6. My answer is now 2. Okay, so now the big question is, well, what happens when there's not enough beads? I'm glad you asked. I'm glad you asked. We we are going to do some modification. Now, what's going to happen is we understand this concept. There's this concept that we understand. We're teaching these children. We're teaching the children how to plus the 4 is equal to 5. We're making it 5. This is what we're teaching the children. Oh, thank you for the like, Agnes. So we're teaching the children how to do this. This is what I called stock. I don't know if anybody knows Tokyo Drift from Cartoons. When Mater goes to Tokyo and he gets modified, this is what it reminds me of. So what we're doing is we're understanding this concept. 4 plus 1 is equal to 5. 1 plus 4 is equal to 5. What we're going to do now is we're going to do some modification. Why are we going to do that? Because we want our numbers to work for us. We don't want some lollygagging, free-loading numbers. No free-loading numbers. Can we say it together? No free-loading numbers. No free-loading numbers. So what's going to happen is we're going to modify it. How do we modify it? What we're going to do is we're going to modify our stock our stock equation. What are we going to do is we're going to isolate the variable. We're going to isolate this variable. Why are we going to do that? Because when no freeloading numbers, right? No freeloading numbers. What we're going to do is we're going to do this addition problem. 3 plus 4. 3 plus 4. So the 4 is what I'm doing. The 4 is what I'm trying to find. Notice I don't have any more beads to add the 4. I don't have any more beads to add the 4, so I need to modify this stock equation. So we have 4 is equal to 5. Notice this is not balanced. Thank you, Agnes. So because this is not balanced, all we got to do is minus the 1. Hey, John, ho, does that make sense? Now what we did is we isolated the variable. What we're going to do now is we're going to substitute this information into the 4. What? What does that mean? Well, what's going to happen is I want to add the 4. That means I'm going to plus the 5. I'm going to add the 5, and I take away the 1. And I take away the 1. So my answer is 7. In abacus, we don't memorize doubles, right? What does that mean? Doubles means 4 plus 4 equals to 8. 3 plus 3 is equal to 6. 2 plus 2 is equal to 4. We don't memorize this. What we memorize is our formula. We memorize our modified equation because it's very versatile. Why? When we look at it, let's take another one. Let's do another one. So instead of 3 plus 4, we can do 2 plus 4 plus 4. Again, we want to add the 4. There's not enough beads. How do I know? Because if you look at it, we don't have enough beads. What we're going to do now is we're going to utilize our equation. Add the 4 equals plus the 5 minus 1. So we're going to add the 5 and we take away the 1. So my final answer is 6. Does that make sense? So what we just did is we're trying to, what was it? It was trying to combine and then, oh, I had it. I had, what is it? Break up the numbers and then recombine them in useful ways. That's what we're doing. Breaking up the number, we broke up this number to recombine it in a useful way. And so what we did is we made it useful. Now we can utilize this for almost any which way. It's now scalable, right? You are renaming 4. Yes, exactly, Marlene. Exactly. Exactly. So when we do 4, let's do 4 plus 4. When we do 4 plus 4, 4 plus 4. We add the 4. The reason why I need to rename it is because I don't have any more beads. So I got to find the money. I got to find the money somewhere. To find the money, it goes to the 5. I add the 5, but that's too much. I want 4. I need to take away the 1. Does that make sense? Show me the money. Whoa. Let's see if this works for the money, right? We have 4. We have 4. But I only have a nickel. So what am I going to do? I only have 5 cents. So what do? I'm going to give you a nickel, but I want my change back. Give me my change back. So then I have what's left. Is that right? We could do that. That's a little bit much. But that's what it is. It's my change. Does that make sense? That's brilliant. Huh. Okay. Yeah. So I think I'm trying to find other ways to explain how to do exchange. The coins are a stellar visual for it. Yes, thank you, Nisa. Thank you. So yeah, I think that's what it is. So you so is this considered 5 base? No. 5 base only means you have numbers from 1 to 5. This is a 10 base because it's decimals. No matter what, this is just decimals. Yeah. Kind of like when you go to the store and they give you a penny and I'll give you, yeah, kind of like that. Kind of like that. I'll give you a penny and I'll give you that. So that's what it is. This is 4. I want to make 8. To make 8, I have a nickel, but I don't have anything else. So I'm gonna give you my nickel, and I take back a penny. Yeah. Yeah. I think that works out very well. But I think it works. Maybe it's for the older kids because the young kids, like at 5, they won't understand it. So maybe if I do this for, I don't know, 7-year-olds and 8-year-olds, maybe 9-year-olds, I think they would understand this. They would understand exchanging. Yeah. Yeah. Okay, cool. So now if you notice, you'll see that there's a number pattern. If we have 3, we want to add the 4. Notice I'm going to plus the 5 minus the 1 and I move it down like this. I'm using 2 hands just to be dramatic, but I don't need to. Right? I want to show you that I'm doing 1 beat on top and 1 beat on the bottom. And when we add the 4, right? We add the 4, that's what it looks like. When we minus the 4, it's the opposite. When we minus the 4, it goes like that. Wait a minute, what? Yeah. So what we just did is now we're building our concept. We're compounding our knowledge. What does that mean? Well, what we want to do is when we add the 4, we can take away the 4 now. We can take away the 4. To set it up, I do 4 minus 1 equals to minus 5. Why? Because everything needs to be negative. When the things are negative, then what do? If the question is 7 minus 4, right? If the question is 7 minus 4, I need to isolate the 4. If you notice, my question is 7 and I want to take away the 4. There's not enough beats to take away the 4. What do? I need to remove the 5, right? So that means if I do minus the 5 plus the 1. So what I'm going to do, I'm going to minus the 5 and I add the 1. See how it's the same but reverse. Reverse, inverse. Reverse, opposite. Opposite. So notice that it's opposite. If I add the 4, take away the 4. Add the 4, take away the 4. Memorizing doubles, there is no negative doubles, if that makes sense, because it'd just be 0. Anything double itself negative is just 0. So yes, thank you, Agnes. It is minus the 5 plus the 1. So now we're compounding our knowledge. We're compounding our information. We're not learning something new. We're just seeing how it can be modified. Does that make sense? Okay. So what does that mean? Well, we can do others, right? And it follows the same pattern because we still have 3 other pairs to worry about. We can do 1, we can do 3, and we can do 5. Does that make sense? So here, if we did 4 plus 3, we know how to make a 5. 3 plus 2 equals 5. Well, what are we going to do? We're going to isolate the 3. Why? Because right now, when I add the 4, I don't have enough beats to add the 3. So what am I going to do? I'm going to modify my stock My stock equation. 3 is equal to plus the 5 minus 2. So I'm telling you, this is the formula, and it's directions. Plus the 5, and then take away the 2. You don't need to think about it. You can just follow the directions. You don't, it's an obvious thing, right? There's no subtle, like, oh, we gotta, because everything is visual. Everything is right there for you. You just gotta follow the directions. Does that make sense? Whew. Let me know if you have any questions. Let me know if there's like any, like, if you want me to stop or slow down or reassess, right? So this is the 3. We could do the same thing with the 2, and we could do the same thing for the 1. Does that make sense? We're okay? Oh, good, Nisa. Thank you. Multiplying is going to be hard. No, Axel. No, please. I need practice to make this. Yes, it's all about practice, right? It's just like playing a piano, practicing a musical instrument. It's all about practice. Okay. So now we know how to plus a 5. Okay, that's fine. But there's a secret. There's a secret at the end of this, and I'll tell you. I'll tell you the secret after I tell you this. What happens when, the question is what happens when we need to do more? What do you mean? Well, when we need to, I'm trying to find my paper. No. Okay. What happens when we have more, when we do more? What does that mean? Well, we did 4 plus 4. We did this, right? When it comes to multiplication division, you need the answer. It's just easier to track. You need to know the answer. It's just easier to track. Yes. Yeah. Yeah, you just need to know the answers and trust the process. So we know this, right? Because we have 4 and then we add another 4. We add another 4. We know we're going to add the 5 plus the 1. We know this. So what we're going to do is we're going to plus the 4 is equal to plus the 5 minus 1. We know this, okay? So my answer is 8. Well, what happens if I add another 4? Wait a minute, what happens? Well, I can't add another 4. I cannot add another 4. What can I do? I can use a 5? No, I can't use a 5 anymore. Ah, nuts. Now what are you going to do? Hi, Iris. Welcome back. I can't use a 5. So what do we do? Well, now there's a thing. There's another thing that we're teaching the kids. What are these kids learning these days? We're learning to make a 10. Does that make sense? We're learning how to make a 10. What? Why? Because we need to do the carryover. Do we remember how to carry over, borrowing? It's like there's so many names for it. Carrying over, borrowing, what else? Trading, grouping, regrouping. Anyways, so that's what we're going to do. We're going to learn how to group and regroup. But notice regrouping, right? Yeah. There's just so much, it's so complex. Abacus makes it really easy. So the first thing we're going to do is we're going to understand this. What does that mean? Well, what does that mean? We're going to do some modification. We're going to do some modification. We do it again. Do it again? What do you mean? 4 plus 6 equals to 10. Look, it's a pattern. We need to isolate this variable. What happens? Whoa, we got to move it over there. Same thing. It's a pattern. Now we see patterns. Now we're solidifying the pattern that we know. So what's going to happen is 4 is equal to plus the 10 minus the 6. What? What does that mean? Well, adding the 10 just means going to the next column over. Remember when I wrote the number 10? Right? Remember when I wrote the number 10? It's a 1 and a 0, right? 1 and 0. When we add the 10, it's the same thing. Adding the 10 is the 1 right here. We're going to add 10. We're going to add 1. And there's a 0. Then what are we going to do? We're going to minus the 6. All we got to do is take away the 6. And now my answer is 12. How did I do that? That's pretty easy, right? Because why? Now we're solidifying our concept. Okay. Okay. Let me regroup. Was that too much? So what we're gonna do is let's do another one. Let's do another one. We'll do 7. Yeah? Oh, beautiful. We'll do 7. It's the same thing. We do 7 plus 4. 7 plus 4. We have 7 on the abacus. 7 on the abacus like that. We don't have enough beads to add 7. So what are we going to do? We go back to our formula. Plus the 10 minus the 6. All I got to do is plus the 10. That's what I'm doing. I'm adding the 10 and I take away the 6. And now my answer is 11. 11. I was wondering if your kids find it helpful now that they're older. Remember you said not when they're little? Yeah, they do find it helpful when they're older. But now they're like in calculus, and so they don't have to worry about arithmetic because they know it. So if that makes sense, because what it is building a strong foundation. They don't they they build a strong foundation with abacus, but when they get into like geometry, because abacus is not about memorizing it, geometry is a little difficult because geometry is a lot of memorization, but they found algebra really easy because there's a lot of framework that abacus uses that algebra does. Why do they make this complicated? Why did they make this complicated way to do math? It's building number sense. Yeah, because the number sense are so strong. I can see that. Thank you. Yeah. Yeah, the biggest thing is because their number sense is really strong. And so like sometimes my he's in grade 6. He gets a little bit confused in his head, so I tell him to take the abacus out so he can do the division and stuff. And he's like, "Oh yeah, okay, I remember." So, I mean, we don't practice it after they finished the curriculum. We didn't practice it because because there was no, I didn't think there was a need to, but I always go back to it when they start getting a little bit mixed up in their head. So, yeah, Axel, why did they make this so complicated? Yeah, oh my God, oh my God. Okay, so I'm so upset. I'm in this math summit, and there's these people talking, and they have all of these strategies and all of these algorithms, and I'm like, there's so much to like they make it, there's so many different ways to get to everything. Just boil it down to the simplistics. Boil it down to something that is manageable. So there was one person, I should say presenter. There was a presenter, and she started breaking up the question. Like she said, 24 times that by 73. And so we're going to break this up into 20. So this is 20, and then this is 4. Okay, now we break this up into 70, and then this is 3. And I'm like, why are you doing all of this? What's the point of doing this? And then made me mad, even more mad. She broke out the presenter broke out like the number blocks, and there was like number blocks. Okay, this is a 10, and or this is 100, and these are tens, and you need to do this. And the presenter was saying that, well, this is concrete. It's like, this is not concrete. This is still just a picture, and the picture is not making any sense. Oh my God, I was so mad. I was so mad. I was so mad because what just I don't know why. I don't know why they're making it more complicated. Because they're like, the kids don't understand. It's like the kids don't understand because you keep shoving down all these strategies into their face. Oh, we gotta learn how to. We wanna make this into. What did they say? They said like what did they say? They said something friendly numbers. They were talking about friendly numbers. Oh, this 70 is so close to 7, so or 70, so we're gonna make it 70, but you gotta keep in your head like a number 3. I'm like, what the fuck are you doing? Sorry. I sorry, Marlene, but I don't like it. I'm so mad. I'm so mad. I just so, anyways, what curriculum do I use? Is there's a specific abacus curriculum, yes. So what I'm doing right now is I'm showing you the ways that we are doing adding, subtracting. Oh, so how do I hear? Okay, good. I'm just oh my god, the presenter was going through and I'm like, why are you making it more like new math? I was like, why are we doing new math this way? The reason why we're doing new math this way is because they got to stupidly write it out. And I'm like, well, why don't just use the abacus? Okay, so before I forget, I will tell you the secret, and I promised I was going to tell you the secret. If you know how to add a 5, how to take away the 5, add the 10, and take away the 10, this is everything you need to know and it scales for all of addition and subtraction. It just depends on how it tetrases it out. It only tetrases. So let me continue a little bit more with this. So we know how to add and subtract. I talked about how to add it to make a 10 and take away the 10, right? We understand that. So now let's do a few more. It's called two-step equation. Oh my god. Sorry. Yes. Well, let's do a two-step equation. I just I don't know. I don't know why it riles me up. I don't understand why it has to be so complicated. I don't understand why there I don't when people start talking about thinking math, like those thinking classrooms, it's okay, that's great, that's fine, but those are for old people. Those are for people that already have understanding abstract thinking. You're talking to 5-year-olds. There's no abstract thinking for 5-year-olds. I don't understand why we're trying to force this. How do you make I don't have time. Just let me show you. It's you know what? You know what? It's just like all the other gurus, right? All the other gurus. You want all these followers, you want to make money online, you know all those things, right? What happens? We hire a teacher that's already done it and then we make it better. That's what we need to do. And I don't understand why we want kids to be their own thinkers when we already know this stupid stuff. We just need to make it better. Show them the way and then let's see if they can take what they have and modify it. So let's take one question. Here, this one is a nice one. This one is 49. Let's do 49 plus 7. 49 plus 7. Oh my god. Sorry. Sorry. I'm just so it just makes me mad. I'm so mad. Okay, so we're do 49. We do 49. We want to add I want to add the 7. I want to add the 7. Thank you, Freeha. I want to add the 7. To add the 7, we know there's not enough beads. You don't want kids to think outside the box. No, I want the kids to think outside the box, but they need to know where the box is. It's like you give them a boundary. It's like I'm not going to just say, "Hey kids, go roam around the world and figure it out." It's going to be like, "No, here's the fence, here's the border. You can go to the border and if you push the limit, then that's fine. Push the limit. Just don't say it's like giving them like everything and then they have nothing and they don't know what to do. So it's not that they can't think outside the box. I figured out how to stream on 5 different platforms because I have my ideas, I have my elements, and then I figured out, well, how do I make it better? So we give you the elements, it's up to you to figure out how does it all Tetris is it all Tetris. That's what that means. So you can if you that's I'm not here to preach how people should guide their children, but as parents, I believe that I guide my children, right? So when I'm guiding, you can run, you will fall. That's fine. Thank goodness you weren't my kids' teacher. Stay out of the kids' classroom. That's fine. But if you don't like it, Teresa, you can leave because this is my room. Sorry. So we're back to here. 49. When we have 49, we have plus 7. When we add the 7, what are we going to do? We're going to plus the 10, and then we're going to take away the 3. So we plus the 10. Notice now we don't have enough room, we don't have enough beads to add the 10. We don't have enough beads to add the 10. So what are we going to do? Do you remember how to add the 1? Add the 1 is minus the 5, take away the 4. Take away the 4. I can block you. You can continue to like make horrible comments, but I can block you. So, so yes, thank you, Iris. So we want to do is we want to plus the 5 and take away the 4. And then what do? We cannot forget the 3. We cannot forget minus the 3. So we want to minus the 3. You take away the 3. So our final answer is 16. I'm sorry, not 16. Our final answer is 56. And that's it, right? So what I'm doing is I'm providing you elements. I'm providing you a foundation. It is up to you to do with it, right? We have clothes. You could use glass on your body to dress yourself. That's up to you. You can use plastic, like the emperor's new clothes. You could do that too. That's thinking outside of the box. But I like to be clothed and I like to be concealed. So it is up to you if you want to use saran wrap to wrap your body. That's fine too. It is up to you. It is your prerogative. I just choose to tell you these are your elements. And if you choose to try to wear mercury on your body, that's fine. You can wear mercury on your body. Is there some repercussions? There's might be, right? You can wear coffee grounds. You can wear coffee filters. I can go on. You can wear anything you want. You don't need to wear clothes that you buy from the store. Think outside the box. Go ahead. You could wear a box. That's fine too. So you can't tell me to think outside the box if you don't know where the box is. All right. Sorry. Okay, I'm done. I'm gonna just sorry. So does that make sense? So what we just did is called a two-step equation. So what we're doing is I'm giving you a foundation, and then you can have to figure out how to manipulate it. What it is we're providing critical thinking. Now, if you notice, we have 49, right? We're back to here. We're adding 49. When we add the 1, the question is how do we add the 1? Right? The question is how do we add the 1? Can we add it? Yes, we can. Just like Bob the Builder. Can we do it? Yes, we can. The question is how do you do it? Right? So what we did is in our abacus, we know that we want to plus the 5 and then take away the 4. So what we're doing is we're going to plus the 5 and then we take away the 4. So notice I don't have any beats. Does that make sense? So when we look at it, it's plus the 4 and then, I'm sorry, plus the 1 and then take away the 3. Thank you, Iris. Yes, exactly. So plus the 5 minus the 4. So those are the bases. When you see it, that's everything you need. You need everything that's right here is all right here. And you'll be able to answer all the questions at scale. And that was the greatest thing. That's what was like, oh my God. So she could have been the presenter that I didn't like. I don't know. I don't. All right. So I mean, it gets more. We can do another one. Can we try out multiplication? I need to get me an abacus. You want to do multiplication? We can do multiplication. So the first thing about multiplication is understanding where we're going to put the answer. Now, what is that? The reason why is because on the abacus, it helps us. We want to use the abacus as a tool. The tool is to keep track of our numbers. So when we do it, the first thing we're going to do is we're going to do out. And also notice, we don't memorize anything higher than 9. So as far as we go is 9 times 9 is as far as we goes. Why? Because it gets redundant afterwards. What we do in abacus is we do, what do you call it? Distributive property. Distributive property. That's what we do. So that is a algebraic term, right? We kind of know a little bit about algebra. And again, this is what we're doing. So what's going to happen is if I did 23 times that by 6, right? The first thing we're going to do is we're going to understand where are we going to put our answer. So 1, 2, 3. We need to count our digits. We count 1, 2, 3. So 3 digits. Right? What does that mean? Well, we're going to count 1, 2, 3. Here is where we're going to have our answer. Our answer is going to be somewhere around here. It's going to either be more or less. It's going to be somewhere. We need to know a ballpark figure. We need to know a ballpark. So what we're going to do is we're going to do 6 times 2. Now, when we do it, we do it from left to right. Just as we talk, we say 23. We don't say 320. So we want to go from left to right. So what we say is 6 times 2, right? 6 times 2 is equal to 12. We add 1, we add 2, okay? I'm going to keep my finger here, and then what's the next number? Well, 6 times 8. I'm sorry, 6 times 3. 6 times 3 is equal to 18. All I got to do I have enough to add the 1? Yes. Do I have enough to add the 8? Yes. And there we go. That's it. So my final answer is, thank you, Axel, for the heart. What's my final answer? Yes, 138. Yes, exactly, Iris. That's what it is. Make sense? So what we just did is we just did multiplication. And what we did is, hello, help. I forgot. Thank you, Marlene. Thank you, Marlene. We can do another one. We can do another one. We'll do 57 times that by 9. Same thing. We got it's a process now. They called it process fluency. I'm like, I don't, there's so many terms. There's so many terms. It just baffles me. So they called it, I'm trying to figure out what process fluency is into abacus. It's been a journey to try to get mainstream math terminology into abacus. So this is called distributive property, and we're going to count it again. So when we count it, we do 3. 1, 2, 3. We have 3 digits. 1, 2, 3. So we're going to start here. The first thing we're going to do is 5 times 9. 5 times 9 is equal to 45. So I'm going to add 4 because it's the 3, right? 3 digits. 1, 2, 3. I'm going to add 4. I'm going to add the 5. And I'm here. Now what I'm going to do, 9 times 7 is equal to 63. So I'm going to add the 6, and I'm going to add the 3. Uh-oh. Now what's going to happen? Now this is a little bit. This is where we have to really make sure we understand how to add the 5s and the 10s. Okay? So what does that mean? I need to add 6 to here. There's not enough beads to add the 6. So it's 6 times is equal to plus the 10 minus the 3, minus the 4. So I need a plus the 10 minus the 4, plus the 10, plus the 10. We know how to plus the 10. Plus the 10 is equal to plus the 5 minus 4. So we're going to plus the 5 minus the 4. That's the 10. That's this right here. That's this right here. What we just did is we substituted this. That's what that is. Now we got to minus the 4. We can't minus the 4. What are we going to do? Minus the 4 is equal to minus the 5 plus the 1. This is what we're doing. Minus the 5 plus the 1. So we're going to minus the 5 and we're going to add the 1. That's what we're doing. And then our answer, oh no, we got to keep going. We have to keep going. Why? Because we need to do the 3. So we got to add the 3. All we have to do we have enough beads to add the 3? Yes. We're going to add the 3, and there we go. So my final answer is 513. Yes, I got on my, oh, hey, that's pretty good. Mental abacus, that's really good. Welcome. That's pretty good. I couldn't do it. I have to use my abacus. I have to use my abacus for that. But yeah, I couldn't do it. I couldn't do it. That's pretty good for the hour after what 10-20 minutes of ranting. That's pretty good. All right, what are we doing? Are we gonna do some more? We're gonna do some more multiplication. Marlene, are you okay? What's going on? Hep, any questions? I don't have one yet. I'm pretty good. I'm getting pretty lost. It's easier to practice when you're here. Oh yeah. I need to understand the substitution, but it is fun. Substitution. Oh, yeah. No, you know how I figure it out is, do you have enough? So you take it one step at a time. So when we were doing the what number was this? It was 45. So 45 plus 6, right? So if we let's do 45 plus 6. So the biggest question is, we take it one step at a time. It's not it's you know all the stuff. It's just taking it one step at a time. So let's do 45 plus 6. Now, this is where it gets a little finicky. The reason why is because there's a lot of steps here. The first thing we understand is plus the 6 is equal to plus the 10 minus 4. This is what we know, right? So the question is, where are we going to put it? Well, if I show you, I want to, I'm 45. So we're at 45 plus the 6. So we're adding the 6. We're adding the 6. I have to go. I'll see you another. Yes, thank you. Thank you, Iris. I'll see you in my next live. Hopefully, I'm not renting. It was just a summit. And I got to go through it. I got to go through it because I got to see what they're talking about. Okay, so we're adding the 6. So Marlene, if you notice, we're trying to add the 6. There's not enough beads to add the 6. So what we're going to do is, we know this, right? We know how to utilize the formula. This makes sense to you, right? We want to do is, we want to plus the 10 and we want to add the 5, right? Yeah, you're good. Have a good night. Oh yeah, thank you. Okay, good. So what's going to happen is, this 10, right? That 10, let's see if I can find my little, I want to add the 10. I want to add the 10. So when I add the 10, right, if you can see it vertically, I made it vertical. Does that make sense? So vertically, I want to add the 10 and I want to take away the 4. Do you see that? So I don't know if that's too much. There it is. How about that? Maybe that's better. So I want to add the 10. Notice I cannot add the 10. It's like isolating. I like the isolating cards. Yes. The isolating cards. Yes, because sometimes we just have too much. What did they I was listening to Austin Kleon, and he talked about an artist takes away things and makes it easier to see, as opposed to everything. So that's what it is we don't want to see everything. We want to isolate what we're trying to do. So does this make sense, Marlene? We want to do is, we want to plus the 1. If we want to plus the 1, we don't have any beads to add the 1. What do we do? What do we do? What do we do? I'm all alone. My dog yells. Oh yeah, right? Yeah, that's what an artist does. It's the artist takes away so it's easier to see. Yeah, that makes a lot of sense. I was following this other photographer. His photography was this big, but then the picture, he focused it on that. So that's what's interesting. So is Marlene, are you still around? Does that make sense? We're gonna take away the 1. We're gonna add the 1. When we add the 1, what are we going to do? We're going to plus the 1. I'm stuck. It's which is which I like, because now I could see what happens to my student. But are you stuck here? Okay. So our number is 45. Do we not do when I want to have my formula is plus the 10. So that's what it is. My formula is, I want to add the 6. I'm trying to add 6 to here. When I add the 6, I see 45. Okay, right. But I'm trying to add 6. There's not enough beads to add the 6, right? Because I have 5. I have 5 and 6. I don't have enough beads to add the 6. So then I know that I have to use my formula. Plus the 6 is equal to plus the 10 minus 4. That's the thing I have to know. That's just hands down. If I need to add the 6, this is what I'm going to do. Plus the 10 minus the 4. That's why I expanded to the next column. When I expanded to the next column, I can plus the 10 minus the 4. That means I have to go to one column to plus the 10. When I plus the 10, there's not enough beads to add 1, because that's what I'm doing. I'm adding the 1. Does that make sense? So if I want to add the 1, if I want to add 10, because 10 is just this. I want to add 1. 1 is the same as 10, but in a different column. So when we're going to add the 1, we have to add 1 is equal to plus the 5, right? Minus 4. So we just substituted this 10. We substituted this 10. And we made it into this. Okay? So what we're going to do is we're going to plus the 5. Yeah. There are 2 substitutions. This is why it's a tricky number. And we take away the 4. We're done with this 1. Now the question is minus the 4. Yeah. See, that's why I feel like addition in the abacus world, we focus heavily on addition in the abacus world. Yeah. So now I want to take away the 4. Notice I want to take away the 4. I don't have any beads to take away the 4. This is where we get to two-step equation. Yeah. Right? Right? Like, but see, you know these. You just need to know how to, you know your foundation. You just need to figure out how to fit it in. Like Tetris, right? I don't know what else can be. It's not like a jigsaw puzzle because that would require that you know what the picture looks like. I think it's more like Tetris. Yeah. So we have to minus the 4. We know to minus the 4 is equal to minus 5 plus the 1. So what we're doing is we're trying to utilize what we have. We're trying to like recycle what we understand. So we have to minus the 5 and we're going to plus the 1. So that's how I get 51. And this is the critical thinking that gets that's being promoted, right? We talk about critical thinking. We talk about how do we look at it and how do we solve it. Whereas in earlier, when the kids are younger and the questions come out, we just tell the kids just do the question. Whereas in abacus, we actually have to ask the question, how do you do it and what can you do to do it? So the reason why I really do like the abacus because it lends itself to ask questions. Whereas if you talk about a piece of paper, it could be anything. It doesn't matter. It doesn't matter what these abstract numbers are, right? It doesn't matter what they say because you can't see it. But because now you're bounded to this physical tool, you know that you can modify. Does that make sense? So like even with, you know, the more I think about it, like even with these things, right? Even with these blocks, the sky's the limit. You can add whatever you want and then you won't be restricted. But that means you have a lot of things that you have to deal with, right? I was talking to a friend of mine and he mentioned that uh, uh, classroom management on these blocks is ridiculous because you have 25, 30 kids and they all have these little blocks and things. You have to make sure that you get them all back. You may or may not get them all back, right? Some of them, I don't know, some of them eats them, some of them plays with them, some of them throws them around, whatever. But the classroom management's kind of interesting. But what I'm saying is this, right? Yeah, I understand those models. Yeah. See, the thing is there's no restrictions. If you think about it, there's no restriction. You can add as many beads as you want, but who's to say that I want to trade it in for a 10? Who's to say that we're bounded by this? But in this, we're bounded, right? We need to know, if I have this number, if I want to do 5, how do I take away the 4? I'm bounded by this constriction, restriction. I'm bounded by this restriction. Whereas these, there's no restriction. So I mean, it's great for the individual to understand the big steps, like to understand to understand quantity, but really your eyes can only see like 5 things. After that, you have to count it or break it up into smaller chunks. And so abacus makes it into smaller chunks. So when we look at it, right? When we look at it, we know that this is 3, we know that this is 5, we know that this is 9. Whereas if I look at this, I go, okay, well, 9, I have to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's fine. But then it's not bounded, it's not restricted to understand, to critically think, right? To critically think, like, well, can I make something out of this? Right? And no, you have to get it to 10. So, but yeah, I think in abacus it really translates to critical thinking. Like, if I have this, what else can I do? And that's why there's the 2 steps, or more than 2 steps. So, but yeah, I that's amazing. First class, excited for the next. Thank you for teaching us. Good night. Oh, have a good night, Nisa. Thank you for joining and listening to me to rant. I don't rant very often about mainstream math. I try my best to find the connections, but today is just not a good day because there's a lot of complexities, and I'm sad that, and I think that was the reason why I'm afraid, not afraid, the reason why I'm trying to figure out how to talk better, how to teach better to teachers and adults and to parents, because I don't want the teachers to learn another thing and it's not intuitive. Because there's so much that teachers need to learn. I need to form new brain works on this, but I like this. Oh, fantastic. Can I ask what grades you teach, Marlene? Because what I want to do is I want it just to be intuitive. I want it to be easy to pick up. I don't want it to be like a hassle. You know what I mean? I don't want it to be something difficult for you to learn. But it is different. But if you solidify understanding that, but that was the thing, making sure that if you know how to add the 5 and add the 10, right? Then you have everything. I taught 3 through 5. Oh, interesting. I am trying to gather a curriculum to match the arithmetic side of the grades, of the specific grades. So the books that I have, I'm trying to be more specific. It's been a little bit for me just because abacus doesn't follow a curriculum like Common Core and stuff. It has its own set of curriculum, and it's just interesting how to be able to marry the two. So, but yeah, if you have any questions, let me know. A lot of it is just practicing, like going through the numbers, going through the questions and stuff. So, huh, yeah. Yeah, no, I don't. I just complicated. I don't. It it's just more complicated. Right, practice makes yeah, it is just really about practicing, right? And you can find you know what? You have the abacus. You understand how to use the abacus. You just take out any of the questions you have at your classes, or any of your classes, your textbook, and you try to figure out how to add it with the abacus, right? Like, oh, like what did I do? I had where is it? Oh, I lost it. Is it here? Where is it? I was trying to find. I was trying to find something. I've lost it. Oh, here it is. Is it here? Yeah. Oh, yeah. Here. Okay. So I would take any book. I would take any book. Abacus is an elegant solution. It would be It can be simple or advanced mathematics. Yes, yes, exactly. So I had um my son's math book, and so what I'd do is I would just take any of the arithmetic. I'm trying to find arithmetic. Any of the arithmetic. I guess this is the wrong one. This is like box models or whatever. Right? So you know how to do, like here, it says here partial products. So we could do this and I'll show you how to do it. So you could take anything that's arithmetic, anything that is adding, subtracting, multiplying, and dividing, anything you want, and you can just take it and you can use it on the abacus. So here's the question. 74 plus 57. All right, so 74 plus 57. So we do 74 times 57. Right? 74 times 57. Yeah, I think so too, Hep. Elegant solution. It's so amazing on how simple it is and yet powerful. So the first thing we're going to do is we're going to understand where the starting point is. 1, 2, 3, 4. How do I know? Because I'm counting my digits. 1, 2, 3, 4. 1, 2, 3, 4. And then we want to do 5 times 7. 5 times 7 is 35. Add 30, add 5. And then 5 times 4 is 20. 5 times 4 is 20. So we want to add 2 and add 0. I'm done with the 5. And then what do? I got to recount. So all I got to do is recount. 1, 2, 3. 1, 2, 3. 7 times 7 is 49. So I had the 4 and I had the 9. I was just about to out on the show and then go with Eminem. What? Out on the show and then the algo blessed me with that's funny. Okay, so what we're doing is we're going to add the 4. When we add the 4, where's the oh yeah, so there's not enough beads. This is where we start going into how should we're going to add the 4. To add the 4, we don't have enough, but notice we got to plus the 4, right? 4 is equal to plus the 10 minus 6. So I plus the 10 and I take away the 6 and then plus the 9. We have 7 times 4. 7 times 4 is 28. I add 2, I add 8. I add 2, not enough. 2 is equal to plus the 10 minus 8. Plus the 10 minus the 8. And then here, don't forget there's an 8 here, so we're going to add the 8. So our answer is 4,218. 4,218. Eve, you're so funny. So, Marlene, you can choose any of your questions that you have and just see if you can answer it. It is efficient. Yes, thank you. Yeah, it's really efficient. It's really quite, it's just like how Hep says, it's an elegant solution. It's an elegant solution and we have our guides. We just need to figure out how to use it. We just need to figure out how to use the elements that we have. Right? There's many ways to utilize what we have, and that is one of them. So this is again, right? This is again our how to make a 10, right? Our modified equation. And what we did, so if you notice, we did not have to do new math. We didn't have to do 70 times 50. We did not have to do that. We just need to know 7 times 5. The reason why it's different is because the abacus tracks it for us. Does that make sense? We don't need to say 3,500. We don't need to say that. The reason why is because it does it for me on the abacus. And that's why it's very helpful. And we have our place values, right? Ones, tens, hundreds, thousands. We have our place values because we have everything what we need. We don't need to do extra work. This gets complicated really quick because it all because why does it get complicated really quick? Abacus, this will scale to like 5 digits times 5 digits. When we think about 5 digits times 5 digits, that's a lot of digits, right? And on the abacus, you could do it. You could do 5 digits. Let's bring it down a notch, right? We could do 4 digits, 1, 5, 3, 8, times that by 3, 4, 7. You could do this, right? Have a great night. You too have a good night. So you could do this in new math. What's the new math? New math, um, right? New math is what? 4,000 times that by 300, right? Because what we did, we just did that. And then we got to do it again. 3,300 times that by 500. That's a lot of zeros. That's a lot of zeros. But what do we do in abacus, right? We just count it. 1, 2, 3, 4, 5, 6, 7. This is enough. Partial product. Yes, it is partial product. We do partial product and distributive property. So we do 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Woo! Right? So we're gonna do 3 times 4. 3 times 4 is 12. See how that's, we just added it to the abacus. We just did 12. 3 times 4 is 12. 1, 2. That's it. I don't need to worry about the zeros that happens in the end because I'm not writing it. So what the abacus does is it tracks our numbers. So then what are we going to do, right? What's next? We do 3 times 5. 3 times 5 is 15. Add 1, add 5. This is also partial product as well. It just happens to be on the abacus and we don't need to work. I mean, you could write it out if you really wanted to. But this doesn't scale, right? This scales. This will scale to any number you want. And it will do decimals as well. And it will not be confusing. It's just it takes time and to go through the process. Oh good. Yeah. Yeah, I truly think it's the greatest thing next to sliced bread. Oh, do you want me to finish it? I can finish it. So 3 times 3 is 9. 9 is a single digit. I go back one column and I add 9, right? And then 3 times 8. 3 times 8 is 24. Add 2, add 4, add 2. There's not enough beats to add the 2, so I need to plus the 10 minus the 8. So I need to plus the 10 minus the 8. What am I doing? 24, right? 8 times 3 is equal to 24. So plus the 8, plus the 8, plus the 2, plus the 4. 24 plus the 10 minus the 8, and then plus the 4. So we're done with the 3, right? We're done. Okay. Now what? We do it again. We count. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I put my finger here. This is why it's critical to hold your abacus, because if you don't, then your answer's going to get messed up. 4 times 4 is 16. So I got to write 4 times 4 is equal to 16. Add 1, add 6. Add 1, add 6. Add 6. Now this is more than 2-step. Why? Because we want to add 6. I'm going to add 6 here. Plus 6 is equal to plus the 10 minus 4. So I'm going to plus the 10. Can't plus the 10. See, plus the 10 is equal to plus the 5 minus 4. Plus the 10 minus the plus the 5 minus the 4. And now I'm here. I need to take away the 4. I'm taking away the 4. This is what I'm doing. Minus the 4. Minus the 4 is equal to minus the 5 plus the 1. Minus the 5 plus the 1. Woo! That's a big one. So that was 16. So what's next? 4 times 5 is equal to 20. Add 20. Add 2. Add 0. What's next? 4 times 3 is 13. 4 times 3 is 12. 3 is equal to 12. Add 1, add 2. Add 1, there's not enough. What do I do? Plus the 1 is right here. Plus the 1 is plus the 5 minus the 4. Plus the 1 minus the 4. And then plus 2. Now what do I do? What do I do? I do 4 times 8. 4 times 8 is 32. 32. Plus the 3 plus the 2. Plus the 3 plus the 2. Oh, I think I did it wrong. Well, we'll keep going. Plus the 3 plus the 2. Plus the 3 and then plus the 2. And then now we're done. We're done with the 4. We're got to go back again. I think I did it wrong. I think I did it wrong because I missed something here. It gets confusing. But it's still the same process. 1, 2, 3, 4. 1, 2, 3, 4, and then 1. So we have to start at the 5th column. 1, 2, 3, 4, 5. Oh, maybe that's what I did wrong. I think I think I did that wrong. Anyways, I mean I can continue, but I think the answer's wrong, and I would have to start over. I would start over. It's different when I have to do it by myself or I have to explain it. So, and it's a big question. But what I'm saying is going back, we don't have to do this because the abacus tracks it for us. Okay, I want to do it again. I really have this problem. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. No. Yeah, 7. 1, 2, 3, 4, 5, 6, 7. That's a big product. It is a big product. Oh, I just got a little bit lost. Okay, you know what? Let me do it without explaining. Maybe that will help me. Okay, 4 times 3. 4 times 3 is 12. 3 times 5 is 15. Okay, 5 times 3 is 9. And then 3 times 8 is 24. 24. Okay, I'm done. So I'm done with that. 4 times 4. 1, 2, 3, 4, 5, 6. So 4 times 4 is 16. Plus 1 plus 6. Plus 1 plus 6. Plus 6. Okay, and then did I add the 1? Oh, shit. And then plus 2. 4 plus is 2. Plus the 2 plus 0. 12 plus 2. No, I did it wrong again. Oh, I know what I did. It's because I forget the 1. Yeah, try it again. Okay, now I'm under pressure. Okay. Sorry. 12, right? 15, 1, and 5. Oh, that's what it is. It's because I forgot the 1. 1 and 5, and then 12, and then 9. That's 9, and then 24 plus 2 plus 4 plus 2. There's Now I'm feeling pressure. Okay, wait, hold on. 4, 5, 3, 8 times that by 3, 4, 7. All right. Take a breather. Take a breather. Let me take a breather. 12, we got that. We're here, right? And then we do this. 5, 15, and then here it's 9. Okay, then 24. 3 times 8 is 24. 24 plus the 2 plus the 4 plus the 2, right? Plus the 10 minus 8 and then plus the 4. Ah, that's what I did wrong. So then we're done. We're done with that. So 16. 1, 2, 3, 4, 5. No, 1, 2, 3, 4, 5, 6. We got to be here. 16 plus the 1 and then plus the 6. Plus the 6. No, I was right there. Okay, so that's plus the 6. And then 20 plus 20 plus 2 plus 0 plus 12 plus 1 plus 2 and then plus 32. Oh yeah, now I got it. So 4 times 7, 1, 2, 3, 4, 5. So here, 7 times 4 is equal to 28. So plus 2 plus 8 plus 2 plus 8 plus 2 plus the 5 and then plus 8 plus the 10. Now 35 plus the 3 plus the 5 plus the 5 and then 21 plus the 2 plus the 1 plus the 2 plus the 1 and then 56 plus the 5 plus the 6. There we go. You guys are funny. That's what I got. So it would, yeah. So that's my answer. That's my answer. 1, 5, 7, 4, 6, 8, 6. Whew. It's been a long time since I did a question that big. But anyways. So yeah, 1, 2, 3, 4. So it's a million. The question is a million. That's beautiful. Oh, thank you. But that took a little bit. It's hard. Yeah, it's hard to present and do big questions unless I took it really slow. Okay. Okay. So that. That is multiplication. We could do division. But division will be easy. Division is not as. Division is a little bit complicated. I don't think it would be beneficial to start division just because it might get complicated because there's a lot of steps to it, if that's okay. So I'll probably stick around for like multiplication. We can do more addition and we could do subtraction. But I think if we did division, it'd be very complicated. Not complicated, but it'd be a little bit more involved because it's a lot of information. So, but yeah. Whew. Now I gotta check it. Oh, I gotta check it. Yeah. All right. So we did that. That's, I mean, and that was the thing, is like trying to get to a point where abacus has the same terminologies as mainstream math. I checked your answer, and oh, good. It was correct. Oh, good. Uh, yeah. But and that was the thing, is like, and I wanted to make more worksheets for like adults and stuff. Thank you. Thank you so much, Marlene. uh, I just thank you. I appreciate that. Thank you so much. Oh, yeah, because I know, and that was the thing. Okay, so that's the thing. Here's one thing. When the kids get it wrong, what I did was I would always tell the kids, go back and do the question again. Sometimes it would take them like 5, 6, 7 times. Like sometimes it would bring my kids to tears. But as they go through, if after the second time they can't do it, you got to take it slower. You got to take it step by step, and then you would start doing the partial product, right? Watching the process was helpful. Oh really? Oh really? Okay. Okay. So when I would do this, like when the questions get big and long, right, and the kids get must like they get frustrated, and that was the one thing that I noticed, that, and I appreciated abacus, that it tests their frustration level, because I want them to really get to a point where they got it. So here, let's say they had a problem, I would keep a running total. If this is too big, right, I would keep a running total. I'd be like 4, 4 times 3 is equal to 12, and I would keep a running total, and as I keep the running total, then we would start like figuring out how to Tetris it all back in together. But yeah, it's one of those things, like looking at the process and then just understanding how to do it. But I knew where I was messing up, and that was the one thing that if they did it again, they would understand where they mess up. So, thank you for the support. I do appreciate that. It's yeah, thank you for the support. It's just one of those things, like I know I'm pushing a boulder up the hill to explain how abacus works. Because one, not everybody knows what an abacus is, and two, they don't know, they may or may not understand the benefits to it. But I feel like the more I just talk about it, the more that I try to relate it to mainstream math. So, but that was multiplication. And that was the one thing about, was it called new math. And new math, I cannot imagine doing new math this way. That would be like, I don't know, overwhelming. I could see why the kids wouldn't like it. So, all right. thank you again for a wonderful night, and it was very eventful. Whew, I don't go on a lot of rants. It was just today was just a different day. But I appreciate you guys listening to me ranting. I do appreciate that. That was like yeah. Anyways, but yeah, if you want to, you can pick up any question and see if you can answer it through the abacus, and that would be a restriction, right? Oh, that was the thing, right? Your passion is great. Oh, that's the thing. I was listening to Austin Kleon, and what he was saying is there's a bunch of musicians, I forget who it was. What they do is they play the piano or whatever, right? They play the piano so well they know it. To make them different, to make them amateur again, they would take it and they would give you and they would ask for a trumpet. Does that make sense? So the idea was to be an amateur again, to try to find different ways to do what you already know what to do. Yeah. Oh yeah, thank you, Marlene. Yeah, I really think abacus is the abacus is the way. I really do think so. And I think understanding how to move the beads and understanding that there's constrictions, I think really helps the kids to understand and analyze and critically think what they're trying to do. I should stop fidgeting. But yeah, wow, there's still 8 of us in the room. If there's any other questions, let me know. If not, I am going to sign off. But yeah, I just one of those things. Yeah, let me know if you have any more questions about abacus. We could talk about any of the questions. You can bring questions, Marlene, if you have anything. I've been asked, like some people have been asking me about like the two-step equation. So they'll give me two-step equations, and I'll show them how to solve it. But yeah, let me know. And then I have my abacus on TPT. I have like worksheets on TPT or worksheets in my website, and I even have it on Amazon. And so you can find my book. This is my book. My name is that's my name. And so you can find my book under that name. But yeah, I'm trying to bless the world, abacus. Yeah. So I'm trying to build more worksheets that are more abacus driven. They're more abacus specific because the questions are very abacus. um like this can be done on the abacus. That's not a problem. But that's obviously after learning more things. Oh good, I'll check it. Yeah. Oh, TPT, it's called learning hyphen Lynette hyphen that one. There we go. So I have, if you wanted to, like, I have this book. Whoa, sorry. I have this book on TPT, and then I have my other book. I still have to fill it out. I mean, I have a lot of worksheets. I just haven't really been up to it. But yeah, it's learning hyphen with Lynette. Yeah. And then if you follow me, you'll get the updates and stuff. Yeah. So there's that. There's other places. There's also my website as well. But I know TPT is just easier. Yeah, not a problem. Not a problem. Thank you for listening to me rant. But I feel your pain, and I know that going through PD, I was trying to make abacus as easy as possible. Like just I wanted to make it easy. So, and this is how I'm practicing. So, if I ever get my big hit, you know that you were a part of this. You were a part of the journey of trying to make it as easy as possible because it's simple to use, easy to understand. I just got to get to a point where cuz that's my goal is to try to introduce it to mainstream, to the schools and stuff. Yeah. We're at the ground floor. We're at the ground floor. Cause if you ever look at like the videos, all the kids are doing this, and you're like, what are they doing? And nobody really teaches us. Or they teach, but they don't relate it to mainstream math. So that's why I talk about isolating the variable, substitution. Those are all the terminologies we're using in mainstream math. We're talking about grouping, regrouping, and that's what we did with the plus tens. In abacus, we just call it plus tens, but in mainstream math, we call it grouping, regrouping, trading, carrying on, and borrowing, right? So that was the reason why I use very specific um, math terminology. But again, it's one of those things like you just need to know these four things. You just need to know these two things, and if you know how to do it, adding and subtracting will be is scalable. All right. If there's no other questions, Marlene, do you have any other questions? Because it seems like you're the only one that's here. Oh, hey, Blue Raptor. I don't know if Blue Raptor's still here, but if there's any more questions, before I sign off, I wanted to make sure I answered any of your questions. But I do appreciate you sticking around. What is the origins of the abacus? Okay, the origins of the abacus actually happened all the way back into the Mesopotamia, which means like when it was right after we started bartering. So when we started putting into the money system, after the money system is when they started to use the thing called an abacus. An abacus really means pushing beads. That's all that abacus means. And so after a while, there's a Russian abacus, which is a 10 bead that goes across. Then there's the Chinese abacus. The Chinese abacus is 2 beads on top and 5 beads on the bottom. And then after a while, the Japanese came around and said, you know what, this is the greatest thing to next to sliced bread, but we can make it more efficient. And so they made it more efficient, and that's what they did. They made the Chinese abacus more efficient. The Chinese abacus still uses the formulas, but it's a little redundant. So when we count 1, 2, 3, 4, 5, 5, and then we have to trade. We have to trade this 5 with this 5 right here. So notice we have 5. And then after 5, we do 6, 7, 8, 9, 10. Again, I'm going to trade it in to this 5 here. So now I have 10. But the problem is, then I have to trade it in again because this breaks my brain. Why? Because we're no longer using it as a place value. What we're using it is just a 10, just a holder. So we got to trade it in, and that would be, now this makes sense. This is now a the ones and the tens. And so it's the same thing with the abacus on the Japanese abacus. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we have 10. But notice if I did 4 and I need to add another 4, I still need to do the formulas. So that's the interesting thing about it. You still need to do the formulas because it's still plus the 5, take away the 1. Yeah. Yeah, it's really interesting. So yeah, that's the timeline of the abacus. Yeah. And now there's another one called a Reck, and that's a Dutch abacus where it's a white beads and red beads. There's another abacus called the Kramer, which is with the backing is solid, and it's harder to move the beads. The Kramer abacus is used for people who are unable to see or have difficulty seeing because they want to make the beads not so easy to move. So these are a little bit stiffer, and that's the Kramer abacus. There's another abacus that Right Start uses, and that's yellow and blue. And they do the same thing, but their abacus is a 10 bead across. So there's 10 beads across, and it's the same thing, just like with the bricks that you with the blocks that you have. I don't know. I don't think they do any formulas, but I don't teach that, so I don't know. I only know the Soroban. That's all I know. I've been teaching the Soroban for 20 plus years. And yeah. Yeah. No, yeah, thank you for the question. That's a very good question. Some people are like, "Oh, the Chinese were the one that invented it." It's like, "No, Chinese didn't invent it. We just, took it from something else and then just modified it." So, any other questions? Yeah, I hope you're able to introduce this to your students. I think it'd be the greatest thing next to sliced bread. And I think you will see the confidence. What is the color-coded one called? This one is a soroban. These two are called soroban. You can find this if you're somewhere around here. You can find it at Daiso. You can even look at it in the TikTok has it. I know there's a few people. Soroban, right? Or you can try and find it at Daiso. There we go. Solomon. Now Soro. Come on. Come on. Come on. Yeah. Then the Chinese one is called a shuo pan, but I don't know where you can find. It was autocorrecting. Oh, yeah, yeah. Every time I say abacus, it gives me advocate, and I'm like, I didn't say advocate. I don't even know how to spell it anymore. Advocate, advocate. Anyways, it gives me advocate. I was like, no, I want to say abacus. Yeah, yeah. Soroban. Or you can find the 13 one. You can find that at Daiso. You can find this one at Daiso. I think somebody was able to find it for like $4. I have a Daiso near me. Yeah, you have to check around. If they don't have it by you, then ask them if they have it around where they can. They know the inventory, right? So ask them if they don't have it. You could try Amazon, but it's a little bit more expensive. And if you wanted to, right, this is a 13 column one. Depending on how big the numbers at, you could get a 23 column one. This one is my 23 column one. Oh my gosh. Come on, buddy, buddy. There we go. Yeah. So this is 23 columns. And this is where it just depends on how big your numbers will get. That's all that means. It just means the amount of digits just means the amount of questions, how big the numbers is. I like the colorful one. I think the colorful one comes in 13, but I'm not sure. I would recommend if it's for you, I would recommend doing at least 13. It depending on how big the questions get. It all depends on how big the questions get. So if you're thinking about doing more like the one that I just did, you would have to use the 13 column one. But if the other one, the three digits or the two or four up to four or five digits, you can use the colorful one. I only need to go to 10,000. Okay, so then this one works out well for you. Then this one, it's not a bad price on Amazon. Yeah, I sell it too on my website, but you don't have to get it from there. Just so you know. Yeah. Yeah, if you only need 10,000, then that's good because, and then you can do decimals, right? So if you choose this to be your ones, right? If you choose this to be your ones, then the rest will be your decimals. Yeah. Yeah, not a problem. Not a problem, Marlene. Thank you for commenting. No, I appreciate your comments and your willing to learn. Yeah, no, thank you. Thank you. I really do appreciate all the comments and the compliments and the questions always really help me to understand where do people get stuck. And that's exactly what you mean, right? Like now you know how your students get stuck. And it's like, yeah, now I know how yeah. Cuz when I was teaching, I would teach kids and they don't have questions. So for me it's hard to solidify my teaching for big people. That's what it is, really. Because for the kids, I just say, memorize it. That's all you got to do. Memorize this. Memorize the formula, and you're done. Whereas for the adults, I like to know why. Why am I learning this? Why am I doing it this way? So that's how I like to learn. So, but yes, thank you. I appreciate you. Thank you so much. I hope to see you in my next live. I am gonna sign off. Is there no other questions? If there's no other questions, I am gonna sign off. I've been on for a little bit. Yeah. When do I come again? I usually come. I try to go live morning. I'm in California, so I'm in Pacific time. So I try to go live like around 8 or 9, and then I do it again like in the evening, about 10 o'clock. Oh, same. So I try to go about 8. Depending on how it is. Sometimes I'll go and we'll do midnight math. So I would be doing like sometimes I come in at like so it's usually sometimes after dinner, so be like after 8, and then it depends on the energy and stuff. Because I am still trying to create my book and stuff. So and I'm trying to publish more workbooks and more worksheets. But I do have people that are starting down the curriculum, and it's exciting. I just it's just one of those things. Yeah. Thank you for the follow. Um, yeah. So I go on. Okay, so sorry. The question is, do I go on almost daily, sometimes twice a day. And if you don't see, and then what I'm also trying to do is I'm trying to stream on all the other platforms. So I'm like on Instagram, Facebook, LinkedIn, YouTube. I think that's it. Yeah. Yeah. And now I'm here. So, oh, yeah. So if you wanted to look back, you can try to find, you can find it on my YouTube channel because it's streaming there and now it's saved. All my rants. It's okay. It's good to have people have different ideas. Yeah. Yeah. Not a problem. Have a good night, Marlene. Thank you so much for attending. Thank you so much for joining. I will see you in my next live. Have a good night.